page. We're not going to be doing the coffee maker. There are no thermal siphons. So we're going to start with a single screen, which needs a view model. And then the view model is going to need a user ID and a repository. And then that repository is going to have local persistence and web, so we're going to need a retrofit service and a room DAO. And then, of course, in order to create the room DAO, we're going to need a room database. And in order to create a room database, we're going to need an application context. Then, in order to create the retrofit service, we're, of course, going to need a retrofit instance. And in order to do that, we're going to need an OKHTTP client, which has a base URL and an OKH and itself. So, before we talk about inversion of control, which is the superset of service locators and dependency injection, we're going to talk about normal flow of control, which is also called control flow or normal control flow. Lots of names. If we were to build this repository using that pattern, and only that pattern, no singletons or anything, we would need to create a room database and an OKHTTP client and retrofit instance, and then we would finally be able to get our service and DAO. Note that I'm actually cheating with this because I'm using app context constant with a singleton, which doesn't, like, so you can't, even when you're cheating with a singleton app context, you've got this huge stack of dependencies that you need just in order to create a class to do something simple like dealing with the web and a database. It's expensive. There's lots of boilerplate. It would be redundant if you have other classes doing the same thing. And it's difficult to test because we're introducing hard-coded dependencies. We would be stuck using a real API with real web calls or a real room database. We wouldn't even be able to use an in-memory database or Rogue Electric to test this stuff. It could be worse. So now let's talk about inversion of control. And we frequently break this down into the two categories that I mentioned, which would be service locators and dependency injection. So by service locators, I mean we're going to use a singleton, which knows about everything, every single dependency in the entire application. It knows how to do it. And then you make a call to the singleton to get either a new instance of something, like a factory function, or singleton instances that we would be able to get your room database from the service locator. On the other hand, with dependency injection, we have two kind of free, but we're going to talk about two different options. You can pass our dependencies into the constructor, which is preferable, or we can use mutable properties within the class itself, either rate inits or you can make them nullable, it doesn't matter. The third way is method injection, which nobody really ever uses. There's a very simple way of method injection, which means just having arguments in your functions, and that's so elementary that we're just not going to talk about it. But we are going to talk about, all right. So there's a twist to service locators. It's a really, really nice twist. Instead of being like a pure service locator, like singleton, doing what we were just doing, you can instead make an interface and then implement that interface with your normal, the thing that a moment ago was your singleton. And then you can inject that into your classes. The benefit of this is that when you're testing, you can just make a mock implementation of that same service locator and inject that in. So you get the benefits of like the ease of use of a service locator, but you're also able to do testing by overriding all of that functionality. So now let's talk about field injection. It's one of the two types. It's the bad one. Say you have a screen and it needs a view model. Screens in Android, whether it's a fragment or an activity, we don't actually have control over when they're created. The operating system is just going to, if you turn the phone, you're going to get a new fragment. If it's in the back stack and you do some garbage collection and it goes away, the operating system has no problem in just creating a new one, right? So we can't pass anything through the constructor into that fragment because the operating system is just going to use a new constructor. So what we have to do instead is this field injection, where we can have our dependencies listed and then set them later via a normal setter. So what this looks like in Android is, well, for the fragment version, you subscribe to some callback in the fragment, and when that happens, you make an external call to a singleton to an injector class and say, okay, I'm ready, please give me my stuff. And forgive the poor implementation, which is scaled very poorly, but I want to call out exactly what this injector is doing. It's not returning a value. If we were saying, injector, give me my view model, then that would just be service location. What we're actually doing is saying, okay, now is when we want you to do something. And then injector can take as long as it wants to actually get back to you. It could keep doing all this stuff asynchronously and take a couple hundred milliseconds to return its view model. So there are three problems with this. First, the view model is being exposed as part of the fragment's API, right? The view model is actually an implementation detail for the stream. It's something that the fragment or the activity needs in order to do its job, but it's not a feature of that stream. Right? So it shouldn't be part of the publicly exposed API. Second, it's mutable. The entire premise of a view model is that it lives longer than the stream does, that it persists through these changes. So the idea that this thing, which is supposed to be holding on to like the important bits of the screen, can be changed is just crazy. Now, I'm sure nobody would ever actually like reset the view model, but why are you making it so that you can't? Well, you have to, but like maybe we can do something better. And then, of course, the third problem is that it's dating it. Now, this code right here wouldn't have any problem with that because it's not actually doing anything. But this code isn't just going to live for today. Actually, it might. But 6 months down the road, 4 feature requests later, maybe we've added some live data that we're observing, or a channel, or a flowable, or a flow rather, and suddenly there's some data that's coming in that means that we need to update something on the view model. So what we're going to do in this observer is reference the view model and then update it. And what if we're doing that before the screen is actually done initializing fully? So that's why we don't do wait init. Also, JetBrains just tells us not to. So moving on away from field injection and into constructor injection, we've got our view model. And we remember that it has a dependency on the repository. How are we actually going to initialize this? Well, the view model is the dependency of the screen, right? So we can create the view model in the screen, but now this is the same old thing. This is normal control flow. This is not what we want to do. It also means that we need to create a repository inside the screen, and that's bad. This is about dependency injection. Well, can we just inject the repository? Well, we can't, and we already talked about that. We can't inject in the fragments, but let's ignore that for a moment. Pretend that we can inject into the repository of the screen. And this is really weird, because the only thing that we need the repository for is creating the view model. So hopefully anybody would look at this for a few minutes and say, why don't we just inject the view model? And that's, aside from the fact that you can't, because it's a fragment, that's screen, this is exactly what we should be doing. because dependency injection is not about creating these dependencies. It's about receiving the dependencies. That's inversion of control creates them, but not dependency injection. But there's a problem with this. We're just kicking the can down the road, right? We need these dependencies in order to do anything with the screen, and now the screen needs them, and now the screen is saying, oh, well, somebody else is just going to give them to me. And eventually you're going to get to a point where there is no more road. And you need somebody to say, all right, no, I'm going to get it. I'm not just going to keep on asking for somebody else. And as a matter of fact, that's where we are. We can't inject the ViewModel, and we don't know how to create it. So what we have to do is to use a ViewModel provider. Right? This is a mock-up of the Android architecture component ViewModel provider, and it's capable of creating the ViewModel for us and giving it to us. I'm realizing now that this is not a lazy init, so this actually wouldn't work. You have to do it by lazy, but that's okay. So the thing about providers like this is that providers are actually part of the service locator pattern. A service locator knows how to return all of this stuff because it has a huge army of providers behind the scenes. And when you ask for something, it knows which provider to ask for. So instead of using the service provider, the ViewModel provider, to retrieve this ViewModel, we can go one step further and just have a locator which will then delegate to a ViewModel provider in order to get our dependencies. Incidentally, this is exactly what Koin does. So we can finally start talking about that. So first I'm going to talk about two classes. These are not, these are classes. I want to be clear about that. Koin is very ubiquitous. The word Koin is extremely ubiquitous within that library, kind of like coroutine, in literally everything in the coroutine library, which is a little annoying. But right now we're talking about a class called Koin. And Koin is essentially the service locator of the library. It has a graph in which it, actually several graphs in which it saves cached scoped versions of objects. And it has bindings and functions for getting the dependencies and putting them in there and creating scopes. And then we have Koin application. Koin application is a wrapper for the Koin class. It is it delegates most of its functionality, most of the calls that it has via extension functions right down into the Koin interface. But it also does stuff of its own. It handles like bulk insertion of modules, which we'll talk about soon, and adding properties to the Koin instance. But it's important to note this is not an Android application. When I first saw this, I thought, the Koin application is like the Dagger application. Just subclass this, and then you're good to go. So, totally different, not an Android thing at all. So next, after we understand that, we have to talk about the global context. This is pretty much exactly what you think it is. Probably. It's a singleton that has a single nullable reference to a Koin application. So this allows you to basically hot swap Koin instances throughout the lifetime of your app, as well as stopping them. And because all of the singleton logic is extracted out into a different file, different class, I guess, it also allows us to have multiple instances of our Koin application and our Koin class. So you can have entirely different dependency injection, the dependency service locator instances running simultaneously within the project, which is really, really helpful when it comes to testing. More on that later. So next, we have to talk about two factory functions which do pretty much the same thing. It's the start of the DSL for Koin. They're both responsible for creating the Koin application, but the start Koin version will also automatically set that Koin application to the global context. So we'll see how we use this in a minute. What it also does is really interesting. It creates clear instances. When you're defining your boundaries in the dependency graph, you can set a flag which says, all right, this class, which is a singleton, is also a God class. And I need it to be initialized right away and start doing its thing without even asking for it. Just do it. This isn't something that you can do in anything else. Like if you were doing Dagger, in your application on create, you would initialize your graph and then call the injector and inject your God class back into your application. And you have to call, my God class dot initialize in Vue. And Koin will just do that automatically for you. But since we're allowed to have multiple instances running simultaneously, it would be really bad if we had multiple God classes trying to orchestrate like whatever it is they're doing at the same time. So we only allow that in the singleton global context instance. So here we are in my application on create. It's not doing anything except it's adding Timber for a reason. If you don't know what Timber is, it's an awesome Android util log wrapper by Jake Warden, and allows you to do like some customization, filtering, and define different behavior for different build types. So, got that out of the way. We're going to just follow the guide here, and we're going to call start Koin in the on create of our application. So now, with the exception of the Timber, immediately we are going to have our Koin instance created and start working with it. So the first thing we do is to add Android logger, because that's exactly what they say to do. But I don't like that. I want to use Timber. Everything else goes through Timber. So what I did was just copied and pasted the Android logger code into a new file, and I modeled refactor. It's an open class designed to be overridden. And now I have a logger which will take all input, output from Koin and pipe it through Timber. Now I've updated my Koin application, and now I'm adding the Android context to my graph with one line. This is actually our first dependency. Congratulations. And now we get to add modules. The modules are conceptually the same as modules in Dagger. They are what hold your bindings and your dependencies and make everything work. So let's talk about them now. Modules are they're logical groupings of your dependencies, but they don't have any real rhyme or reason to that grouping. You can just, however you want to organize them, just go for it, and it works. Unlike Dagger, they don't have a hierarchy. It's just a flat list of them. Let's make our first one. So there's another keyword. We had start Koin and Koin application, and now we have module. And that's the intro into the DSL. It's a normal function that takes a lambda. And now we get to put something in it. Keyword number 4, factory. Factory is another function which takes another lambda. And every time, so a factory, every single time you request a dependency, it's going to invoke that lambda again and create a new instance. So let's put something in it. Let's put the repository, which is currently a no-arg repository, or no-arg constructor. And this is the DSL. So sometimes DSLs look like they're magic. and like there's all kinds of hidden rules, and you just kind of follow the documentation, you don't step away from it at all. That's not the case here. It's really just a lambda. So you can do whatever you want. You can have all kinds of logic inside your lambda. You could run large classes through it, but I obviously wouldn't recommend that. So now we've defined our first dependency. And I want to talk about nomenclature for a second, because it's a little confusing. The documentation sometimes calls it a bean definition, and the code, the class name is a bean definition. But Arnaud, the author, usually calls them components. So from here on, I'm going to try to be consistent and refer to a component. When I say that, I mean this is a factory inside a module, or some of the other things that you put inside modules. And this is completely unrelated to the dagger component, totally separate things. So now we've defined how to do something, but it's not connected to anything, so we need to connect the graph. Right? When we defined the Koin instance, we made this reference at the bottom to a Koin demo module, and then I really just glossed over it and moved on. That's a list. It's a top-level list stored in some file somewhere, and it's currently empty. I like having it stored as a list instead of just throwing it into the application itself, because then you can reference it elsewhere, like maybe for testing. Or if you're creating multiple modules and multiple Koin instances, then you can reuse it. So let's add our new module to the graph by adding it to the list. And that's all there is. Now it is connected. Koin knows how to make our repository. So that repository, though, has dependencies, and they're currently hard-coded, right? So now we need to fix that. We can clean this up considerably by removing the hidden dependencies entirely and just taking the service and the DAO as constructor arguments. And we can make them private since, well, we're not doing anything with them. External. Oh, sorry. We make them private because if we want to test this, and of course we want to test this, testing is awesome, then we're going to have references to them already because we have to inject them in. So we don't need to make everything public. So now we've broken our module, right? This thing requires 2 arguments in order to actually build. We can access those arguments just by using get. That's it. Add names, because that's good practice. But get is an inline reify function. It's able to infer the type. And because it's able to infer the type, you don't need to do anything else for it to figure out what kind of dependency you need. But this won't work yet because we haven't actually added components for those 2 dependencies. So let's do that. Create 2 more factories. And in order to actually make those work, we're going to need to add those same dependencies that we had hidden in the repository class. So there we are, creating an OpenHTTP client and the retrofit instance, and then we're finally able to really create the service. And I want to call something out about this. We're using get not for constructor parameters, but as tools with which to build our dependencies, right? Particularly in the case of my service, right? We're creating an object and then using it and then just discarding it. Get is able to do that. So now let's do the same thing with the database. And I want to call out 2 things with this as well. First, we're making use of that Android application that we added in Start Koin. And second, I think this is, I don't know why, but it's absolutely fascinating to me. The DAO, we're not actually creating it. It's already created by the Veeam database, and all we're doing is accessing it. which I don't know, it's just, it blows my mind just how weird that is. One thing to note here, this is pretty difficult to read, to figure out what's going on. And we can make that better. This is my 2 cents. Just Koin. Let's just, there we go. Let's just explicitly state the types. Right? Now the IDE is actually going to yell at you for this, so you need to suppress the warning. I love this regardless, because it keeps everything is nice and aligned, and you can quickly scan it and see which component is doing what. Love it. So next we have to look at this module's efficiency, because all of these are factories, right? So we're doing the same thing that we were doing, it's a lot better, and it's cooler because we're deploying lambdas, but we're doing the same thing that we were doing with the normal control flow, where we're creating a new instance of everything every time we need it. And we don't need to do that. So let's use a different keyword, and let's make everything a single. Ooh. So there's no annotations or shared instances or anything else you need to do anywhere else. In order to make something a single, you just use different keyword. You note that we're not going to bother doing that with the factory because the factory to the DAO, because it's already a singleton in the room database, and all we're doing is accessing it. So, speaking of access, now we need to access the graph elsewhere. We're able to call get and get components from within the module, from one component to the other, but that doesn't do us any good if we can't access them outside. We need to cross that wall somehow. So let's go back to a screen which needs a repository. It conspicuously is not part of any class hierarchy at all, but for some reason it wants the repository, so let's get it to it. This would work. This is referencing that global context singleton. We're calling get, which gets you the Koin application, and then accessing the Koin instance, and then calling get, which gets you the repository. But this is really gross, and you're not going to keep on doing that. But what you can do is use a marker interface that Arnaud wrote that's Arnaud Giuliani, by the way, the author of Koin. If you just add something with Koin components, it has extension functions for convenience to get you that Koin instance, so you don't need to go through all that boilerplate. But it gets better. If the screen is actually a fragment, of course it is, then we get this for free. There's an extensions library for Android, which gives us all of these extensions for lifecycle components. That's using component callbacks. So activities and fragments and services never need to implement the Koin component interface. So thing is, though, that the screen shouldn't be dealing with repositories, right? The screen should be dealing with ViewModels. So let's give it a view model. We need to make a new module, and we can use another keyword here, which is called ViewModel. It does the exact same thing as a factory, except it's going through ViewModel providers. So it will create a new instance if needed, but otherwise it will just use the one that's cached in that provider. Meanwhile, we need, and then so don't forget to add that to your modules list to just magically add it to the graph. Meanwhile, in the fragment, you could be doing this using get with that nice architecture components extension, but you don't want to. You don't have a lifecycle yet. This is on initialization, so it's before you're attached, and you want to be lazy. So what we can do instead is to use the ViewModel keyword in a different way, and now this will lazily fetch the ViewModel object for you. So What if you're not doing a view model? What if it's your repository that you really, really want for some reason? Well, there's another keyword, inject, which does the same thing for everything else, but it doesn't involve view model providers. So what about parameters? A really long time ago, I mentioned a user ID, right? Well, that would have to go through the constructor. How do we do that? Yep, we have to add it to the. Yep. So we add it to the view model in the constructor, and then this once again breaks our module. So we have to go into the module, and remember I also said that the component is just a factory. Sorry, it's just a lambda, and it can be anything you want. So that includes lambdas with parameters. So you just add your integer parameter, and then it'll work really simply. Meanwhile, on your screen, instead of using by view model with empty parentheses, you instead pass a lambda in with a parameters of object, and that will automatically generate the object which has been parsed in order to invoke the lambda at the module site. So moving on, next we have to talk about scope. We've already been talking about scope, but not really, kind of. We've been talking about the two extremes in scope, which would be creating a new thing every time and then never creating a new thing at all. And what if you want to do something in between? A typical use case would be a login session, right? You create a preferences object for a user, and then that persists until the user logs out, and then you kill it. So Koin handles this as well. You have a scope object and a scope definition. In your module, you create a scope node looking for a name of login, and anytime you see that, then you use another keyword, this time scope, to create a component which lasts for the lifecycle of that scope. The name collision here is driving me nuts. I don't know how to describe this. So it's so bad. So we have to add this to the modules list, and then from anywhere you like, you can create a scope using the ID and that same name. So ID is a compound key, I guess. The ID makes it specific to a single user, and the name references the type of scope you're looking for. So when this user logs in, they get a preferences, it sticks around until they've logged out, and then you have to explicitly close that scope, and everything will be destroyed. And of course, Android gets it better. So with Android, we already have all the scope handling done by architecture components. So we have an extension function which gives us this current scope, and instead of defining a name in our module, we just tell it the type of class that's going to be creating the scope, and then all the scope handling is automatic for us. So next, dynamic features. Anybody using feature modules? Dynamic feature modules? Me either. I don't like them, but one of the reasons I don't like them is the inability to actually reference anything in the application while the feature module is not loaded. So what we have to do instead is define everything in that feature module, define a lazy bar to initialize stuff only once, and then when the activity is initialized, the entry point into that module, you could just call the code features thing, and it would add everything to the graph, and then you can just move on normally. Oops. And we're running out of time, so go through the testing really quickly. This has always been a problem with Dagger. Constructor injection makes testing easy, but Dagger makes it hard because you can't override modules. First we're talking about compile time. My bad. So everybody says, oh, Koin isn't safe, you don't have compile time checks. And that's true, you're not testing that your code works every single time you want to build, but you're also not running all the unit tests. What we do have is a single function at the bottom there called check modules. And it will run through every single module and make sure that everything that's requested is able to be used. So it's not exactly the same thing, but it's really similar, and it does it without a ginormous build time. So last thing is overriding modules. For any component that you make, you have the ability to add this override proof tag, which will do exactly what you think it does. And so you can have a normal implementation in your graph, and then create another module, load that on top of the other one, and then whatever stubbed out functionality you've added will just automatically work. So that's it for the talk. Here's some further reading. There are two different types of documentation for Koin. These ones with the link are extremely good, and the last one is the GitHub. If you have any questions, please reach out to me. Here's all my social media, email. This is the Kotlin link, Slack. Again, I'm Rick Busarow. And I don't know if we have time for questions. Probably not. Nope. So if you have any questions, please just walk up.